Hello everyone, this is Asghar Nazir. Today we will discuss about the relational operators. Relational operators are operators just like arithmetic operators or assignment operators. These relational operators, they are used to compare two data types, to compare two values. For example, if I have to check if two numbers are same or not, if two variables contain same value or not, if a variable contains a value greater than the other variable or not. So for these kind of comparisons, we use the relational operators, and these relational operators, they are very important. For example, if we want to build programs which can take decisions based on the data, we cannot write those programs without these relational operators. So these relational operators, they are very important, and some of the examples are, let's say for example, you are building a program which checks if your hard disk is full, it should not allow to store more data. This is not possible if we don't have the relational operators. Let's say you are building another program like Zoom or Slack. If the internet goes down, it checks it, it continuously checks it, and the moment it goes down, it displays a message that, hey, check your internet connection. Similarly, if your date of birth is equal to the current date, then maybe your program displays happy birthday to you. So all of below scenarios, they are only possible if we have something that we can use to compare two things. If we cannot compare the date of birth with the current date, we cannot take any decision whether we should say happy birthday or not. If we cannot compare the current capacity of the hard drive with the total capacity of the hard drive, we cannot take decisions whether we should allow to store more files or not. So all of these kind of things that we do, they are all possible with the help of relational operators. Now let me tell you the types of relational operators. The first one is the equal to operator, and check this out, we are using two equal to sign. It's different than the assignment operator. In assignment operator, we use the single equal to sign. So this double equal to checks if, let's say, there are two numbers, a number x and a number y, it will check if the x is equal to y or not. If x is equal to y, if both the numbers are same, we will get a true as a result, otherwise we will get a false. Also, one more important thing, the result of applying a relational operator to a number or a variable is always a boolean. You will always get the result in the form of true or in the form of false. So in the second example, we are checking if x is not equal to y. So this x can be any number, y can be any number, and if that is true, if those two numbers, if they are not equal to each other, we will get a true, otherwise we will get a false. Similarly, if we have to check if a number x is greater than a number y, we can use this greater than operator and it will return true if x is greater than y, otherwise it will return a false. Similarly, it is the opposite of the greater than, it checks if x is less than y or not. If it is indeed less than, then we will get a true, otherwise we will get a false. And then this last one, it checks if x is greater than or equal to y or not. So it checks two conditions, whether x is greater than y or x is equal to y. Any of the conditions is true, the end result will be true. You can imagine you are bringing flowers and chocolates to your wife. Your wife says, okay, you bring chocolates, I am happy. If you don't bring chocolates, you can also bring flowers, I will still be happy. So either you bring chocolates or flowers, any case, any condition is true, the end result is true, your wife will be happy. But if you don't do both of the things, you don't bring chocolates as well as you don't bring flowers, then the overall result will be false and your wife will be angry and this operator will return false. So if any of the condition is true, that's good, we will get a true as the final result. If both the conditions are false, we get a false. And this is the opposite of greater than equal to, it's the less than equal to, and it checks if x is less than y or if x is equal to y. Any condition is true, we get a true. Both the conditions are false, we get a false as the overall result. So now let me show you a demo. So let me create a new class. And now let me create some examples using the relational operators. So now let me explain what is going on and how they are working. In the first condition, I am checking if the number 10 is equal to 20 or not. Here x is 10 and y is 20. As these two numbers, they are not equal to each other, we will get a false. We will get only true if the numbers on the both side, if they are equal. So for example, if I copy this and if I paste this, and if I put the same number on both the sides, then I will get a true. In the below condition, we are checking if 10 is not equal to 20. Yes, indeed, 10 is not equal to 20, so we will get a true. Below, we are checking if 10 is greater than 20. Again, 10 is not greater than 20, so we get a false. Is 10 less than 20? Yes, it is less than 20, so we get a true. And below here, we check two conditions. Is 10 greater than 20? No. Is 10 equal to 20? No, because both the conditions fail, the overall result will be a false. The overall condition will fail. However, if I put something like this, if I put 10 greater than equal to 10 or not, then we will get a true, because 10 greater than 10 is still false, but 10 is equal to 10 is true this time, so we will be getting a true. Similarly, if we write this condition like this, is 11 greater than 10? Yes, that is true. Is 11 equal to 10? No, it's false, but because we have got one condition as a true, so the overall result will be a true. And here we are checking 10 is less than 20. Yes, it is less than 20. Is 10 equal to 20? No, but because one condition is true, the overall results will be true. We can also use the variables to perform these calculations. First, let me show you the results for this program so that you can compare the outputs. So for the first condition, we get a false. For the second one, we get a true. For the third one, again we get a true. For the fourth one, we again get a false, and you can similarly compare the other results. So now let me create another class and let me show you how we can perform this comparison with variables. So here I have created two variables. One I have called as number1, the other one I have called as number2. In number1 I am storing 100, in number2 I am storing 120. So now I am doing the exact same thing as I did previously, but here I am using variables. So again the results will be exactly the same. The only difference is that here I am using variables. The number one variable contains the value 100, the number two contains the value 120. They are not same, they are not equal, so we will get a false. Is number one not equal to number two? Yes, that is true. 100 is not equal to 120, so we will get a false, and similarly we will get the results for the remaining things. So let me run this code, and from here you can compare the results. So first is false, second is true, the third is false, again true, false, and again true. So it's the exact same thing but with the help of variables. Now we can also apply these relational operators with the float data type. So for example, if I change the data type from integer to float, it will work exactly the same. Let me run it, and as you can see we get the exact same results. We can also use these operators with the char data type. So for example, let me replace it with the char data type. So with the char data types, it works exactly the same as it works with integers or with the floats. The only difference is that behind the scenes, computer uses something called ASCII table, and that ASCII table has a representation for these numbers. For example, if I print out the number A and if I typecast it to an integer, so if I say character A and I try to typecast it to an integer, you will notice that we will get a number and the number will be 65. So computers, for everything behind the scenes, they use numbers. So what will happen, all the comparison for these characters, for these chars, will happen based on this number 65. Similarly, the number behind the character B is 66 in the ASCII table. So all of these comparisons will be happening behind the scenes based on the number 65 and 66. So you can apply almost all the relational operators with the char data type and you can get the same exact results. We can also use these relational operators with the boolean data type, but with the boolean data type, not all the relational operators are supported. So for example, if I change this data type from char1 to boolean, so as you can see, with boolean, only the equal to and not equal to operators work. The other operators, they don't work. So let me comment them out for a second so that we can run the code, or let me delete it. And now if I run this, I will get the proper results because char1 contains true and char2 contains false. So true is not equal to false, so we get a false, and char1 is not equal to char2, that's why we get a true. Similarly, we cannot also apply these operators, these relational operators, with the non-primitive data types. For example, the string data type. So let me bring back the code and let me change the data type to a string and abd. So as you can see, again the greater than, less than, greater than, equal to, less than, equal to, they don't work with the string data type, again just like boolean. So we will not be getting any value, rather we will be getting a compile time error. And also these two operators, these two relational operators which work with the string data type, they are also not recommended. They sometimes they will work, other times they will not work, and you will get incorrect results. So for example, if I'm trying to create the string with the help of new operator, so although both of the strings, they contain the letter A, but if I try to apply these relational operators to these strings, you will notice that I will get incorrect results. Also, although they are same, string1, str1 and str2, they both contain A, but I get a false here. And if we want to compare the strings, the proper way of comparing the strings is to use the equal to method. So let me replace these with the equal to methods. This is how we are supposed to check if two strings are equal to each other or not. So if I run this code, this time I will get proper results. Yes, both of the strings, they contain the letter A, so we get a true, and the letter A is not equal to the letter A, so we get a false because they are same. So that's how we should be using the relational operators. Let me repeat it again. Relational operators, they are made for primitive data types. Don't use relational operators with non-primitive data types like string. Even with the primitive data types, not all of the relational operators work with all of the data types. For example, as you have seen, they don't work fully with the boolean data type. Only equal to and not equal to operator can work with the boolean data type. And it will make more sense in the next video. I will show you how to use these relational operators and the if-else conditions in Java to write programs which can take decisions. So if you want to learn more about the relational operators, please watch the next part of this video, and then it will make much more sense that how these relational operators are actually used in practice to write programs which can take decisions. Bye bye, take care, don't forget to subscribe and hit the bell icon. I will see you in the next video.